application. So our next one is bridge rectifier. So bridge rectifier is if modified form of, I can say it is the modified form of full wave rectifier. So I'm going to make the circuit even more stable by incorporating additional elements. See here in bridge rectifier, I'm going to have a bridge circuit, and on the one side of bridge circuit, I'm going to have SCR. On other side, I'm going to have diodes. So SCR2, SCR1, D1 and D2. So I'm going to form a bridge structure. So this is called as a bridge in electronics domain. So bridge will have 4 arms. In 2 consecutive arms, I'll be having SCRs. In 2 consecutive arms, I'll be having diodes. And these 2 SCRs will have a common trigger circuit. And I connect the output across, I connect the load resistance RL and I measure the output across RL. That is going to be V0. And same way, I'm going to use a transformer here for operation. So the operation is simple. When I'm going to give a positive during the positive half cycle, this upper portion is positive, lower portion is negative. So SCR2 will conduct. Sorry, this is SCR1 and 2. They have given the numbering. See, the numbering is same as this one, SCR1 and 2. In the diagram, the numbering is wrong. This is 1 and this is 2. Okay. This is 1 and this is 2. So during positive half cycle, SCR1 and D1 will conduct. So you get, after a particular firing angle theta, you get the conduction for the remaining half of the positive half cycle. So during the negative half cycle, the polarity is going to be reversed. So I get negative here, I get positive here. So SCR2 and D2 will conduct. So for the negative half cycle also, I have conduction after a particular time. So this is going to be the conduction area. So that is what is given here. See, so during the positive half cycle of input, SCR1 and D1 will conduct, whereas during the SCR2 and D2 will remain off, because for negative gate current, you know that the SCR will not conduct. During the negative half cycle, the other pair of SCR2 and diode 2 will conduct, whereas SCR1 and D1 will not conduct. And the conduction angle and other thing, this conduction angle, firing angle and all, you can adjust by using the gate current of SCR and SCR1 and 2. And the output voltage, the average output voltage expression is going to be exactly same what we got for full wave rectifier. It was Vm by pi into 1 plus cos theta. So when you put theta equal to 0, you get the answer as 2 Vm by pi. So that is what we got the answer for full wave rectifier. It is going to be exactly same for bridge rectifier also. And how you are going to turn off your SCR, the logic is going to be same. If you are going to reduce the current to a value below the holding current, you are making the current less than the holding current IH, then the SCR will be turned off. Otherwise, you cannot turn off an SCR using gate current. So gate is used to turn on an SCR from off state. But if you want to turn off an SCR from on state, the only option what you have is you have to reduce the current below the holding current, or you have to reduce the voltage below the holding voltage. So SCR is a very, very important device with respect to electronics, where a controlling operation is required, and various applications of SCR are there. And we have just seen the 3 applications of SCR, one as a half-wave rectifier, one as a full-wave rectifier, and one as a bridge rectifier. So we have seen the 3 applications of SCR. So any doubts or queries you have in SCR, I'm going to pause for a few seconds. The floor is open for queries.